Okay, so 18.1 linear inequalities, and I just mentioned this, but sometime next week, because we're only doing 18.1 and 18.2. Okay, so sometime the end of next week, we will take an assessment over 17 and 18. Okay, because 18 just has 2 sections in it. Oh, this didn't copy too well. Oh, you're done. Awesome. Oh, I need one though. Miss Wilson is going to come around and pass out this paper to go in your notes. Sorry it did not copy too well at the top here. And if you're at home, just get yourself some graph paper and fold it like I'm folding it. Or cut yourself out some little graph papers to go in here. But I'm going to take this and fold it in. I'm going to take the outsides, fold it into the middle, like this. Take the left and the right side. So if I'm looking out with the graphs open, take the left and the right side and just fold it in there where the lines meet. And it's supposed to say when in slope-intercept form. What is slope-intercept form? What is the form of that line? What's it look like? Y equals, yes, y equals mx plus b. Okay. Okay. So linear inequalities, turn to that page. We'll title it Linear Inequalities. And then once we get done with this, we'll just glue this right in there. Okay. I'll give y'all a moment to get that set up. So before, we were just graphing the line. We start on the y-axis. I caught that today. Woo. We'd start somewhere on the y-axis and graph the slope, plot some more points, and we would just graph that line. Yeah, with a lot of points. Linear inequalities are not going to have the equal to symbol anymore. They're going to have inequality symbols. So where this was y equals mx plus b, we have an equal sign there. Now it's going to be an inequality sign. Okay. Nope, because that's not equal. So what are the inequality symbols? Greater than, less than, greater than or equal to, less than or equal to. Those are what we're going to see now. So I'm going to talk about all 4 of those and what they would look like. Okay, so we're going to have y is greater than or equal to, and then we can just say mx plus b. Okay, so that's the symbol, greater than or equal to. Then we're going to do, I like to do color coding here. Then we're going to look at when y is less than or equal to mx plus b. Okay, so the difference now is it's not an equal to symbol. So we're not just going to be drawing a solid line and being done. There's going to be a lot more going on with the graph. All right, then we have, if this is greater than or equal to, let's look about when it's just y is greater than mx plus b without the equal to or equal to line. And then the last one, y is just less than mx plus b. So if you're at home, guys, just get a piece of computer paper or graph paper and fold it in. Okay. So those are the 4 types of linear inequality when they're in slope-intercept form. Because you cannot graph unless the line is in slope-intercept form. Okay? That was way back in 17 or 10.1 when we did graphing lines. All right, so let's open up on the inside. First, we're going to talk about this greater than or equal to 1. So when I open up on the inside, I'm only going to talk about this first top left, okay, that quadrant. So let's just work through an example and then we'll graph it on the little graph here. Okay, I made them really small numbers, so don't worry, they'll fit on here. Okay, so the example. Everything's the same way solving it to get in slope-intercept form. The only difference is the graphs. You're right, Zane. Okay, so I'm going to give you 2x plus y is greater than or equal to 1. Can I graph that? No. What form is that in? I'm hearing it. You're going standard form. This is in standard form. AX plus BY equals C, even though it's not an equal symbol, okay? This is in standard form. We can't graph it until it's in slope-intercept form, okay? So what do? How do you get this in slope-intercept form? Oh my goodness, guys. Subtract the 2. Remember, we want the y to be by itself. If it is in slope-intercept form like this, I want the y to be by itself, okay? So we got to get this x term off of here. So minus the 2x, minus the 2x. Now I'm left with y is greater than or equal to negative 2x plus 1. There is my linear inequality in slope-intercept form. It has to be in slope-intercept form to be able to graph it, to know the intercept, the y-intercept, and the slope. All right, so let's graph this. Where do I start at on my y-axis? 1, the slope, the y-intercept there. So that's your start point, so you start at 1. If you forgot how to graph lines, go back to chapter 10. Okay, that's all about graphing the lines. Okay. And then the slope is negative 2, or you could think of negative 2 over 1. So what does that tell me to do? Down 2, right 1. Down 2, right 1, down 2, right 1. How can I plot points on this other side? Right, do the opposite. Go up 2, back 1, up 2, back 1. I've said this before, try to plot as many points as you can on the graphs that you're given so that your line is as accurate as possible. Now I'm going to draw a solid line. Okay, solid line. Let's talk about shading. This symbol right here, okay, that symbol, the greater than or equal to, okay, greater than, well, I think it's easier to think of the line first. So it's going to be a solid line because it's or equal to. So we're talking about the solutions, okay, the points that are satisfying this linear inequality. If it's a solid line, all of the points on that solid line are solutions, so it's a solid line. Okay? And then greater than means you shade above.
Oh, I saw this on the calculator.
Yep, you can do shading above or below on your calculator.
I was just messing with it.
And how you do that, what I would recommend, because sometimes it's hard to see above or below, and I don't want you to think left or right. Think shade above or shade below. Go to some points on the graph and draw lines up or down on the vertical line. So shading above is going to tell me shade up. So you have to shade that whole half plane. I would like a yellow highlighter, not a green one. Whatever, I can use a green highlighter. It'll be fine. I just don't want it to blend in with my kind of bluish green. Thank you. Okay, so then I'm going to shade everything on, this is called a half plane. Okay, that is called a half plane. Okay. If this line were to keep going out and out and out, it would be all those solution points to that side of the line. Okay, these are the solutions. All the points on the line are solutions, and then any point in the shaded half plane is a solution. Okay? Any points in the shaded half plane are solutions. And on the line, since it's or equal to and has the solid line. Okay. Nothing out here. None of these are solutions. All right. Let's move over to the less than or equal to kind. Okay. So let's do an example. What color is that? Green.
And I just took it there, so it's want to make the same, but it's going
You shade below. Solid line, we're going to shade below the line though, because it's less than. I'm not going to do any work on this one. I'm just going to give it to you in slope-intercept form. Y is less than or equal to 3/4 x minus 5. So if it's already in slope-intercept form, okay? So I'm going to graph this line. Okay, it's still the same way of graphing. What is different is the line itself and the shading. So where do I start at on my y-axis?
-5.
-5. 1, 2, 3, 4, 5. So down here. Now what do I do?
Go up on the right foot.
Okay. Anyone else besides Zane know what to do? Up 3, right 4. This is rise over run. 1, 2, 3, 1, 2, 3, 4. Okay, that's all the points I can plot on my graph. That's enough. I can have 2. Since it is less than or equal to, the or equal to means I'm going to have a solid line. Whoops. Solid line, but the less than tells me I'm going to shade below the line. Okay, shade below the line. So let me draw my line here. There's my line. Okay. Now what I'm going to do is I'm going to go to those points and I'm going to shade straight down. Okay, you go to the line itself and then either shade up or down on those vertical lines. So if it's shading down, I'm going to shade the half plane below it. Okay. And these are the solutions. Is 0, -5, is that a solution point? Yes, it's on the line. Okay. Any of these points, even the ones that aren't true points, any of the points on this line are solutions. And then let's say 5, -5, that's a solution. But -5, 5 out here, is that a solution? No. Okay. Points on the line and anything in the shaded region, solutions. All right, now I'm going to move down to the bottom where these symbols are just greater than and less than. They don't have the or equal to with them. Okay, so let's talk about if it's just greater than first. So previously above that we had greater than or equal to, solid line shading above. Now, maybe X is, or the example, Y is greater than X. That looks kind of strange. What is the Where would you start at for that line? The origin? What's the y-intercept? Do you see a number over here? No, so you could put 0. If you like to see it be mx plus b, if there's nothing out there, you can put 0. And then yes, we would start at the origin. What's the slope? Don't tell me it's x. X is a point or a coordinate. The x and the y are all the points on the line. What is the slope? Zane, you're not allowed to talk anymore. What's the slope? Yep, up 1, right 1, because this is like 1 over 1, right? A 1 in front of it. Okay, thank you, Brady. Up 1, right 1, up 1, right 1. No. Down 1, back 1, down 1, back 1. Okay. Now, hopefully you did not draw a line all the way through those points, because it's not or equal to. So this is kind of like when we were doing inequalities with just x. Remember I had an open circle or filled in circle? And then we shaded left or right on the number line? Same thing, but the way you establish that on a line is you don't draw a solid line. You draw a dashed line. Okay, so this one's going to be dashed line. And we're still going to shade above. So what I mean by a dashed line, she's just going to come through and just kind of like I said, dash it. Don't draw a solid line. That tells me that the solutions on the line are not included. The points on the line are not included. Maybe we should add that here. Points on the line are not solutions. That's what that means. Okay, and then we're going to shade above. So I'm going to go to it, some points. I'm going to shade up on those lines so I can see which half plane I am shading. So along that line and then everything up this way. Okay. The thing that might be a little different or unusual to think about is now the points on the line are not solutions. They're not solutions. Only the points in the shaded region. Those are the solutions. Even though we see these points here, they're actually not solutions, because if you plugged in the x and the y into here, you would not have the number be greater than the other number. It's always going to be less than the other number. Previously, when we were just dealing with linear equations, it was an equal to symbol, so the only solutions were the points on that line, because it's equal. Okay, it's just that line. Now we have it's either equal and greater than, so it's the line and then above, or it's just the inequality greater than, not on the line anymore because it's not equal to, just the shading part. Let's look at the last one, which is just less than. What are your thoughts? It's going to be a dashed line. And we're going to shade which way? Below, right. Okay. Now I am going to give you one where we're going to have to do a little work. Okay. So let's look at the example. Negative x minus 2y is less than negative 8. What? How would I start graphing that? You can't start graphing that because it has to be in slope-intercept form. What would be the first step to getting this into slope-intercept form, which means the y is by itself? Okay, so actually, like, what would be the inverse step I would do? Speak up. Huh? No, you're wearing a mask, right? I can't hear you.
Get rid of add the x over to the other.
Thank you. Add the x. I want y'all to actually tell me. Yes, get rid of the x on the left side, but I'm going to do that by adding the x off of the left side over here with the -8. And now I have -2y is less than. What are you going to write over here? What do I write over here? If I'm going towards slope-intercept form, remember it's probably helpful to have the slope term first. So the variables term first. So I'm going to put x and then the -8. Now what do I do? Divide by -2. What else gets divided by -2? The what? Yep, the -8. Do I divide the x? Yes. Remember, anytime you multiply or divide an equation or an inequality, you do it to everything. You also have to divide the x by -2. It may be helpful to put that little 1 coefficient in front of the x. So you can see that that's actually a -1/2. Okay, you're going to have to use your brain now. Way back when we were solving inequalities, what did you do when you divided by a negative? Change the sign. Same thing applies here. If you divide by a negative number, flip the sign. Okay? Same thing that we did back when we were just doing a single variable, when we just had x's. Now that we have linear, meaning we have x and y, the points, if you divide by the negative, like we did right here, you must flip that sign. Ugh. Can y'all do me a favor? Is that what you meant? Okay, in the beginning, y'all do me a favor and switch those. Greater than symbols. So now what symbol is it going to be? If I flip the greater than symbol, what's it become? Oh my goodness. Less than. Now it's the less than symbol. I screwed that up, didn't I? Okay, we're going to assume that I had planned for it to flip and started it out with the greater than symbol. Now we flipped it around. What's the slope?
1, -2.
So I'm going to say -1/2. -1/2 x, because 1 divided by -2, usually we don't keep the negative in the denominator, so -1/2. And what's -8 divided by -2? Oh my goodness. Okay, yes, +4. So now here's my line. In slope-intercept form, what I did is I was trying to make that step happen. And I was like, oh, I don't need to change everything around so I can make sure I divide by the negative. But I didn't change the sign. Whoopsies. Okay. How do I start graphing this line? 4? Can you elaborate on that, son? 4y. So on 0, 4, okay. 1, 2, 3, 4 on that y-axis. Zane has exhausted his speaking time. I want to hear from the rest of you guys. Otherwise, I'm thinking we need to do a bunch more of these together. Show me, tell me that you know how to do this. How do I plot more points? Okay, thank you. Down 1 over 2. Down 1, right 2, down 1, right 2. That's it. I'm going to go up 1, back 2. Plot as many points as you can for the most accurate line, and it doesn't look all squiggly out to one side. Tell me about the line. Is it a line? Is it a solid line? Since it's just less than, it's not or equal to, that is a dashed line. Which way do I shade? Shade down. Shade below the line. So I'm going to make a dashed line. Dashed line, and I'm going to shade below. So if I went to some points and I drew down, I can easily tell which half plane I'm going to shade. Thank you. Tell me about the solutions. What would be considered solutions in this linear inequality? What are considered solutions? Yes, Jordan. Anything below the line. What about these pink points? No, that's where you gotta be careful. Even though I plotted those points, they're not actually considered in the solution. Okay, that's usually the new thing that we have to think about. Okay, so I would expect you to think that the pink ones were, but in fact they're not, because once I did the dash line, they became not solutions anymore. Only if it had a solid line connecting them. Okay. That is your notes for today. You do go on to Khan Academy. There are let's get that glued into your notebook. Glue that page into your notebook. And then there are 2 assignments, 2 practice assignments on linear inequalities that you're going to be working on.